So in my last video, we got rather lucky when connecting to the UART. The device had no protection for UART hacking, and we didn't even get prompted to log in. This isn't always the case, and when we can't just get a root shell from the UART, we usually have to go and extract the firmware or get the firmware somehow and examine the firmware and look for vulnerabilities within the firmware that can then allow us to hack the device. So one of the easiest ways to get a firmware off of a device is to visit the device's page with the manufacturer, do some Googling, Google dorking. So this is the device that we rooted last time. And if you come here and we just go to support, you can see right down here, we can download whatever firmware we want. We could download it for whatever hardware version we have, and we can see what the firmware is, and we can straight up just download it. This is great because we don't need any hardware, we don't need any other tools. We can just download it, and if you're running a Linux machine, you can just go ahead and start examining the firmware that way. This video will go into looking at extracting firmware off a device. This is called, I believe it's like an in-circuit firmware extraction. And this is where we will extract the firmware from a chip that is still on the device. So now we're going to go look at that. So here we have the Wi-Fi router that we've been hacking. Should look pretty familiar with the UART and everything. But if we flip it over to the other side, we see right here, this is an SPI chip. Now this chip interacts with the firmware and the hardware on the device, and it's what we're gonna target today in order to extract firmware off the device. To do this, there are a few different ways. The preferred method is to desolder the chip and put it onto a reader. A reader like this could have an adapter for it, but this is a cheaper and somewhat safer alternative. There is a slight possibility you can fry the device when doing this, so you don't want to plug it into any external power because it will be getting power from the programmer that we're going to be using. This is my preferred method because I'm not great at soldering or desoldering, and that can cause a lot of damage to the chip if you do it improperly. So the device, the tool we're going to use today is a CH341A programmer, as you can see right here. I will put a link in my bio of where to buy it on Amazon. It's relatively inexpensive, which is another great thing about it. And how this is going to work is we're going to plug this end into our Kali Linux virtual machine, and we're going to clip this onto the SPI chip. So in order to hook this clip up to our programmer, we just need to insert it to this adapter, and then we take it and insert it into the programmer. Now if we flip the programmer over, we can see down here that the first 8 are for SPI and the last are for I2C. And since we're doing SPI today, we will put it in the first 8 right here. Now once we have it plugged in, we'll just clamp it down to secure it, and now we're good to go. One thing I would like to mention is, one, you want to ensure you have a really good fit on the chip, because if you do something like this and you only get like 3 of the pins, you're not going to get a good read of the firmware. You'll just get an error. So you want to make sure you have a good secure clip on it, which I'm not able to get right now. But once you get a secure clip on it, then what I like to do is to plug it into my computer. Now, what you might notice here is when you plug it in, you'll see this light shines really bright and then it dims. So this usually means that our clip is orientated incorrectly. So what I found to fix that is our clip was initially set up like this. We're just going to flip it this way. So now with it plugged in, with it clipped on this way, we should get a good connection. So yeah, now that we have it clipped on, we can just plug it into our computer. And as you can see, this light stays bright. Now we'll just head over to our terminal and look at the command that we're going to use to pull the firmware off of this device.
So now back on our Kali Linux virtual machine, first we need to install flash ROM. It can be just installed with sudo apt install flash ROM. And then once we have that, we're going to come over here and we're going to run this command. I didn't run it live because it takes about 10 to 20 minutes to run because this isn't the fastest way of getting firmware off of a device. But here we're running flash ROM with verbose and we're telling it to output to this firmware.bin. And then here we're telling it what programmer to use, and this is our programmer that I showed in the video. And here you can just see it's just probing for the different types of chips, and it will automatically detect the chip. If it detects different, like multiple chips, it will ask you to select the chip. But here, down here, you can see where I'm highlighting, it found the chip that's on the specific device. And then it's just pulling the data off the device. Here it's still probing and found it. And then if you see we run the ls command, we have the firmware.bin. So now what I like to do is use a tool called binwalk, and binwalk will let us extract the firmware. So with binwalk, we're going to use the arguments tag m and e. So this will make a separate directory for the outputs, and it's going to tell binwalk to extract everything out of it. So now we run this, and you'll see it takes a little bit, but it's pretty quick. And as you can see, it's just recursively going through the bin file and extracting everything. So now we have the firm.bin extracted. Now if we were to go into this, now we're inside of the file system. So we can see like we have a squash fs here, we have 7-zip here, but then we have what has been extracted. So we want to look the squash fs root directory, right? Because that is essentially the root directory of our device. So here we're in the squash fs root file system. If we run ls, we see a lot of directories that are similar to a Linux file system because this is just a really restricted and smaller Linux file system. So if we go to the etc directory, we can see there's some interesting information here. Because this is more geared towards what to do if we are asked to log in at the UART, we're actually going to look at the password and the password.bak. So if we were to run password.bak, we actually do get a password hash in here. So in the next steps, we'll look into cracking this password hash. But right now is a great time to look into the entire file system. Um, you would want to examine the entire firmware and see if there's anything else you can leverage. There's some certain common places you would want to go, so like the initd directory, which has the RCS. So this is a file that will run on boot for the device. So as you can see, this is some of the stuff that will run on boot. And a lot of these commands will look familiar to what we were seeing with the UART because these are the commands that are running on boot. In another video in the future, we're going to look into editing this file and adding our backdoor. And this will allow us to get a backdoor into this device whenever it runs on boot. Another great tool, there's a few great tools, but this is a pretty good tool to look at. It's called Bugproof, and there's a free version of this website, and you can upload 2 bin files a month. So essentially, you would just upload the bin file that you extracted, and it will automate going through the bin file, and it will return back a lot of interesting information for you. It will automate finding vulnerabilities and stuff. So it's a good tool to have, but you always want to make sure you're checking manually as well, just in case the automated tool misses something or it gives you a false positive. So now if we just go back and look at this password.bak file, you can see here, right here, we have this admin hash. So obviously we just want to save this and we can just put it into a hash.txt file for later. So after we save it here, there's a few things we can do. One, we can run a hash analyzer on the hash file. And here we have MD5 crypt. So we know it's an MD5 hash. So what we can do here is use a tool called Hashcat, which is a hash cracking tool. TAC A0 stands for a dictionary attack. Then we'll do TAC M500. So M sets the mode, and 500 is for MD5. Now we'll give it our hash.txt file, and then we just got to tell it which word list to use. So we're just going to use the built-in Rocky word list that's in Kali Linux. Here, I already cracked this hash, so we would just show it on your machines. It would take a little bit to run and find the hash, but you should pretty quickly be able to find the hash. Another thing we can do is just use Google. So if we Google it, the first thing that comes up is a GitHub repo. And this guy goes through pretty similar steps. But if you come down here, you can see he does the same thing and he cracks the password. So we get the root password of, or the admin password of 1234. So now that we have the hash, and we crack the hash, and now we have a root, not a root, an admin password, we can mess around with the device more and see what possibilities this opens up. If this device did have a login on the UART, it's likely this admin password would have been the password for the UART login, and we would have been able to get a root shell on the device. My next video will look more into firmware analysis and looking at how to backdoor the firmware and upload it to the target device in order to get a shell that way. So we can get a shell every time it boots up, get a persistent shell, and get a remote shell. And yeah, we'll look at some of the protocols that it has out and what ports are open, and maybe look at more what we can do with these admin credentials.